Problem 11. We are given, consider two concentric circles of radiuses 17 and 19. The larger circle has a chord, half of which lies inside the smaller circle. What is the length of the chord in the larger circle? So in other words, we are trying to find the length of an entire chord such as this one. But before we solve it, we are given a special criteria, which is that half of the chord lies inside the smaller circle. So that means if the outer circle's side lengths of x and x were to be established, then the inner circle must be 2x, because it must be the same distance. So with this, let's know that this is concentric, so they share the same center, which is probably right here. And if you were to draw out the radii, we have a very special figure, which in geometry says that if we were to have a chord and we had the center circle right here, this height would be a perpendicular bisector. This is easy to prove. If you were to connect the two endpoints, these are the same because they're radii. So isosceles triangles, the height is always a perpendicular bisector. Thus, if we were to apply to this question, we can solve the answer. First, let's draw out all the radii connecting the circle, or connecting the triangle within it. So that's a terrible line, so let's redraw it. This would be 17, this would be 17, this would be 19, this would be 19. If we were to draw this perpendicular bisector, what would happen to 2x? Well, 2x divided by 2 perpendicularly bisected would be equal to x, so each side would be x and x. So from here we can solve the question. If we have this half triangle to consider, and this to be a radii, this would be x, this would be x, this would be 17, this would be 19, this would be h. We can use h to relate the x's together. What I mean by this, let's consider the smaller triangle, where this is x, this is 17, this is h. H squared plus x squared is equal to 289 by Pythagorean theorem. And we also know that in the larger triangle where the base is 2x and the hypotenuse is 19, the height is h, we know that h squared plus 4x squared gives 361. And these are perfect squares that you should know. Just for math, you should probably know, be worthy to memorize the perfect squares from 1 to 20. So they're pretty much a guarantee to show up in most AMCs, so it's worthwhile to memorize these perfect squares and these ranges. So first of all, back to the question, if this would be the equation 1, this to be equation 2, subtracting equation 1 from equation 2 will eliminate the h's and leave us with only x. Therefore, we can solve for x. So 3x squared must be equal to what? That must be equal to 2 and then 72, so x squared must be equal to 24. So x must be equal to 2 root 6, because this is 4 times 6, square rooted. So this means this is x, and we're trying to find the entire chord. Well, the entire chord, if you look back up, what is the total length? Well, we have 4 x's, so it needs 4 times x to be our answer. So 4 times 2 root 6 will give you 8 root 6. If we scroll up, answer choice E has that answer, so we are done.